archaeological visualization and heritage. I'm joined today by my co-PI of LIAVH, John Sucuoglu, who's the Director of Spatial Analysis and Visualization Initiative, or what we call SAVI, here at Pratt Institute, as well as our graduate assistant, Priyashi Galiawala. She's currently in the graduate architecture program here at Pratt. So we're delighted to share with you our current research work on digital approaches to neighborhood analysis, data management, and 3D reconstruction of DKG South Mohenjo-daro. So if we can go to the next slide, John. So just to give you some sense of what we talk about when we're talking about LIAVH and the kind of work that we're hoping to do. We have here, sorry, I'm just looking at the slides. So the Laboratory for Integrated Archaeological Visualization and Heritage is really trying to make connections between technology, archaeological data management, and heritage practice. And what we've done with this lab is that we'll have many different smaller projects that the lab as a whole takes, but really we're focusing in on kind of open source technology and ways in which we can make data accessible to more publics and more people, scholars, communities alike. Our first sort of iteration, our first sort of pilot is called MLab, and this is the inaugural project. And we're locating it in the ancient 3rd millennium BCE city of Mohenjo-daro in Pakistan. Just so that you know, LIAVH is, has multiple sort of collaborators. We have a very large kind of group of graduate students who are kind of working with us. We're also collaborating quite heavily with Shah Abdul Latif University in Khairpur, Pakistan. Here you see some of our, actually, if you can go back to slide 3, John. Yeah, okay. So here you see some of our collaborators, some of our team members, in our lab. And we're working hopefully with some of the graduate students at Shah Abdul Latif University from the Department of Archaeology. So there's a very sort of intentional program building and capacity building that we're doing in Khairpur as well. Let me move now to the actual topic, and if we can go to our kind of background of what we're looking at. So this is a familiar slide to many of you know the site of Mohenjo-daro, but just to give some background, Mohenjo-daro is located in contemporary Pakistan in Sindh province. And it's considered one of the main urban centers. We've heard a lot about the different urban centers here in the Indus, and it's extending well over 100 hectares, some even posit up to 250 hectares. The archaeological site itself is located in a semi-arid region of Sindh. It's situated on a Pleistocene ridge in the floodplain of the Indus River. And although this ridge is now deeply buried by annual flooding, most archaeologists agree that the city was probably more prominent in the 3rd millennium BCE, standing out above the surrounding plain. The ancient city sits between the Indus to the west, the Indus River to the west, and the Ghagar Hakra to the east, geographically situated in an ideal position for both trade and farming on the alluvial floodplains. And a lot of studies have already been done on the irrigation canals and irrigation work that's happened in the floodplains itself. So given the arable nature of the land, there's so much robust agriculture that's been developed in association with an extensive network of canals. Excavations at Mohenjo-daro document hundreds of dwelling houses and large buildings constructed along streets and lanes, and you can see some of these on the slide here. The streets and lanes oriented towards cardinal points, which index an architectural sophistication of a well-planned city. Again, something we're all familiar with. Early research on the site recognized it as part of the 3rd millennium BCE, with subsequent excavations over the next 40 years, uncovering the densely built up urban area and continued studies of material culture until present, right? This is an active space. The last major excavation was carried out by George Dales in 1964-65, after which excavations were no longer permitted due to the issues of conservation, right? The exposed structures from weathering and the rising water table. Small scale sort of excavations and test trenches have been done subsequently. Now, if you look to on the left side of the plan of Mohenjo-daro, where it says DKG North and South, you can see here that there's the stupa mound, right? Or the citadel, the Acropolis, the Mount of the Great Bath. And it's separated by the lower town, which is to the right. It's important for us to kind of recognize that the project that we're trying to do right now is quite located in a specific neighborhood, but we are looking and thinking about the larger city structure at whole. So this expansive lower town, which is where we're kind of focused, it's made up of numerous lower mounds that have been excavated over the years, and you'll see those in color patches, including DK, HR, VS, and SD areas, and an extension of the lower town called the Munir area. Now, the lower town has usually been the locus of architectural and residential study. Archaeologists at Mohenjo-daro consider the various areas of the lower town to have been vibrant urban neighborhoods. And so it's one of these vibrant urban neighborhoods that will be the focus of what we're presenting today. And our work draws upon and emerges through our engagement also with previous studies that have been done in these neighborhoods of Mohenjo-daro, including my late advisor, Greg Purcell's work, the work done by Michael Janssen and his associates at ARPM, like for the past 50 years, as well as more recent work thinking through neighborhoods by Monica Smith and other South Asian contexts, and in what Mark Neuer calls an Indus tradition when it comes to thinking of households and neighborhoods. More recently, we're also building and thinking through a recent paper by Adam Green, which looks specifically at publicly oriented structures of Block 8A and 6A, also in DKG South, in which he utilizes an interpretive 3D model. So our work really fits into an ongoing genealogy of work and research in this topic and area. Our main aim is to provide the infrastructure to manage the sheer amount of data that Mohenjo-daro has produced so that we can ask new and different questions rather than our usual queries related to public or private buildings or questions related to craft technology, all of which are really important questions too. But one of the things we'll see is as we are able to look through different kinds of data, we can actually ask different questions of the ancient world. DKG provides some of the most robust, extant, and contiguous architecture on the site, linked to alleys and major roadways, evidence for at least two-story houses, evidenced by the tall extant shaft wells, distinct residential and potential non-residential buildings, extensive waste and water management, bathing platforms, excavations of different time periods, rebuilding of walls, artifacts scattered through time. And all of this is what we're trying to capture, right? So this is what we're actually going to be talking through. Now, the study presented here relies on the archaeological excavations conducted under the guidance of Ernest Mackay. Now, this is an important part of how we're rebuilding this. Large-scale excavations started in the DK area in December of 1927, and it went on until March 1928. So during the first season, Mackay was assisted by Mr. Majumdar, who was the Assistant Superintendent of Archaeology for Exploration, as well as Mr. Shrivastava, who was a scholar in that department, and the excavation assistants with Mr. Devi Dayal Mathur. The second season, which was October 1928 to March 1929, Mackay is assisted by Mr. Majumdar for a short period of time, but Mr. Shrivastava continues for the whole season along with Mr. Roy, who's an anthropologist from Calcutta University. Mr. Shrivastava continues on with Mackay for both seasons 3 and 4, and Mr. Kayan Puri serves as excavation assistants for seasons 2 to 4. The plans that our study relies so heavily upon were drawn by Mr. Mukherjee, Mr. Nawabuddin, and Mr. Mohyeddin. I bring these names up for very important reasons because we tend to just talk about the excavations of Mackay, right? But the decisions that Mackay is making in these during his excavations are being discussed and thought through with a collaborative team of individuals. And so it's important to begin to recognize the people who are doing perhaps a lot of the work. Right? I want to have a quick note on stratigraphy, and then we're going to kind of move into the actual data sets. So for the purposes of the study, we're looking specifically at Block 7 in DKG South. So in addition to the relative stratigraphic consistencies in these specific excavations by Mackay, the use of section drawings from the original reports, the drains, and the door sills provide multiple points to assess stratigraphy. According to Mackay's excavation reports, all the work done in DKG area used one bench level, which was 178.7 feet above mean sea level. The locus and level of every object found was recorded. and all the objects found in or near the foundations of the building were assigned to the period of the building rather than the previous phase, unless it actually rested on the remains of the pavement of the earlier date. Now, these measurements are also reported in Janssen's work, who stresses the disconnect between raw measurements and the archaeological context. And it's a critique we took quite seriously as we were thinking through this. In light of the fact that we can't recreate sediment profiles, we ensured multiple lines of evidence to help reconstruct the stratigraphic sort of layers of the site. The relevance of all this fine-tuning, of course, comes up once we talk about how we're creating these digital data sets. So if we can kind of go through to the next slide. What you see here is, so there are a couple different steps we began with. So the first thing we did was we digitized and georeferenced all the excavation plans that McKay had. We did that also with Janssen's work. We've then gone through and converted all the tabular data of pottery, beads, metals, household artifacts, etc. And we've moved that from the book, right, into an Excel sheet. And we're going to show you an image of that very soon. We've also extracted data from excavation reports using OCR, or optical character recognition. We're looking at door sills, infrastructure, water features, and other elements to identify stratigraphic levels. We've taken the images, the plates from these excavations, and linked them to the actual data set. And here I'm going to pass the floor on to John to talk through some of the ways in which we've done this. John?
Thank you, Uzma. So following up from where you left off, if we move one more slide, you can see a glimpse or a sample of the database that we've been putting together here. And using the 4 images of the artifacts you can see above, their representation in our database can be seen at the bottom in the database format. And doing this database, our initial idea was to be able to query the database, connect the objects into their locations using the house numbers, room numbers, block numbers, go through the books and identify if there's any text or paragraphs relating to these objects or any information, and then bringing them back into the data set as well, so that it becomes a comprehensive data point that we can visualize in many different ways. We can make scatter plots and maps, or we can just look at data itself. And if you look at the final version of the data set, you can still actually, it is quite complicated. It is not as straightforward as it was seen in the image before. And the main reason is that a lot of the descriptions for artifacts were in written format, and they were very difficult to actually convert them into a tabular data. So in a narrative format, 2 different locations might be defined for an artifact. Some things are just noted as not clearly known. So we had to come up with very different ways to accommodate this information. So for, let's say, for example, for objects, sometimes we have 2 columns identifying locations. And one of them will be the first location. The second one will be, of course, the other location that was mentioned in the text. And the very first thing, of course, as it's my instinct to work in data visualization quite a lot, is to plot the data and to see what is going on. And here what you see is all the artifacts that we have put into our database that are shown for different blocks, and the different size of circles are showing how many objects were found. As this was an initial study, we realized that using, when we used the height to show where the object was found and the block numbers, it is very difficult to also compare it with the locations in the map. And also we had to use some more complicated tools to be able to show the multi-dimensional information, such as the narrative text that was written in the books. artifacts are not the only data set that we're trying to create. Actually, at the end of the day, we've decided to have one data set that can hold both artifacts, water features, floor features, so that we don't have to keep on joining things every time that we want to make a visualization, but still, as the initial data collection, there were separate databases. So as an example, this is the floor features. And a lot less about the floor features can be found in tables. They're mostly in drawings, or again, they're in a narrative format. And all the fantastic graduate assistants that we had over the time that Uzma showed, they've done really painstaking work going through the book over and over and over many times to put together what you see here. And again, different visualization showing artifacts overlapped with floor features here. The floor features are the longer lines, the artifacts are the dots. And as we have kept on working, now we have over, I think, 1,500 data points for artifacts, and I think several hundred data points for floor features, and a little less than maybe 100 for water features now. So as the number of data points that we have kept on increasing, we had to come up with our own classifications for objects. They're very preliminary, so theoretically speaking, some of you might not agree at this point, and we're still working on having different classifications. So I might agree with your disagreements as well at some points. But then what we try to do is to understand how the stratigraphy or the time as it's divided into categories work in Mohenjo-daro. And we thought if we were to take all of the objects and understand the highest and the lowest points defined to belong into a certain time periods, we can start to kind of create our own stratigraphy and see if actually things match together. And this is a very crude attempt of doing it. Since it's tied only to the objects and the heights that were found, you can see that it kind of moves around a lot. I know that there shouldn't be gaps in between, but it's just the data is showing it that way right now. And the final visualization that we're working on, I'll try to give you a live demo. I'll see how well it works in Zoom. If it doesn't, I apologize, but on my screen at least it's working. So before I go into it, let me explain what is going on. So we try to combine the geographic locations on the map together with the height and the block numbers, because sometimes looking at the location information as a categorical variable is almost easier to identify sometimes as like a block and house number. Right now, we've eliminated the option to look into room numbers because it gets really complicated. Not a lot of objects have a defined location. Some of the objects only have block numbers, so it was getting very complicated. We thought we'll just leave it at house resolution for now. But what we are trying to do is actually to be able to give a glimpse of the multidimensionality and all of the information associated with artifacts and the features in one table. And so you can see the depth, geographic locations, clustering over time. You can filter the objects by time periods, and also with hover overs, you can see the class of the objects, the feature type, the text descriptions that we have isolated from the book, and also you can see the images. The images might be a little bit low resolution because we're struggling with actually getting good scans of the book, and some of the objects are just small. So let me try to give you a live demo. If it doesn't work as well as I intended, I'm sorry about that. All right, it seems to be working. A little slower, but it is working. So you can see that this is a more updated version of the same visualization. So now all of the objects can be seen expanded into the geographic locations that they belong to. And when we hover over a specific object, we can see the descriptions that I just showed, but also we can see, maybe you can see it on the below right, there, one of the dots are a little bigger. That is actually where the object belongs. And as someone who's coming not from archaeology but from architecture, for me, I struggled quite a lot to understand this categorization of time. And I always thought, like, the depth of the object should actually mean the time as well. But Uzma has been very patient in explaining this to me, how it works. So we've created this filtering function in the, let me find you a little bit of a bigger one. The filtering function that you can filter all of the artifacts by time periods, and not only in the scatter plot. I mean, it's kind of obvious in the scatter plot, right? Like as we go down, the time period goes backwards as well. But when we actually apply the same filter into the map, I think the results are quite interesting. I mean, as a data, it's interesting to me as a data visualization person. I hope as archaeologists it's interesting for you as well. And of course, the early periods are defined a lot less, so there's a lot more objects fall into that category. Is there anything you want to add to this, Uzma, with the visualization, or should I continue the presentation?
Yeah, no, I think one of the things that this is, because remember, this is going to be an open source kind of tool. What this allows us to do is query different time periods and see the change, the diagram, the change through time, which is a really important factor. And as John was saying, so much of the data is buried in narrative text. So when you just go to look at the plates, or you just go to look at the tabular data, that's not actually everything that's happening at the site. And so it's been quite remarkable to see when we first did it with just tabular data, how few data points we have, and then how it expands as we look at this. And this, again, it's available online, free for everyone to use. We'll have it as an open access thing. You can see it through time, and you can also see it as it moves around in terms of spatial location. But yeah, I think we can move on to the next slide.
Let me say a few words about the open source as well. I mean, coming from the data science community, working open source is the norm in my field. And I think it is very interesting to share that what we're doing. Currently, we're still building the databases that I talked about, and they're not final, so we're very hesitant about sharing them yet. But as soon as we're comfortable with the information that we have in it, we will share it on GitHub, so it's easier for everyone to pull and replicate the information as well. Also, the visualization that you're seeing is built, all of the visualizations actually you've seen were built using open source tools, Matplotlib, Plotly, and the final one that you're seeing is D3. And as we're building it, we're trying to document what we're doing as well as we can, because especially with D3, with the final tool, it is very easy to copy and paste things together and to build your own tool using what is done. So as long as you have some kind of a location information, block and house, and all the accompanying information that we have, you can actually apply a very similar thing to your own site as well. All right, so I am back in the presentation now.
Yes, thank you.
And after talking about data visualization for so long, I will leave the word to Priyashi as well to talk about architecture a little bit.
So in this plan, as you can see, we are trying to develop a digital model of the selected part of the plan that is DKG section South block 7, using an analog system, trying to look for information that is present in the plan, and maybe it's not present in the text. As we can see in the legend on the side, what we are trying to represent in the plans and digital model are the features such as wells, kilns, cesspits that are present in there, which gives a sense of infrastructure of that time period. Can you move to the next slide, please?
I'm sorry, I'm trying to find my mouse. Yeah.
Okay. And here we see we started with the 2D plans, and then we did the, in here we can see that we are trying to relate the information with the sections and the plans that we have, and we are trying to figure out the different features and details that we are getting in to understand how we can develop this into a 3D model and it becomes clear. So what you'll see in the later slides is not something that is like entirely one. There are like different pieces of information that we have gathered, combining to one to come up with the model to get a sense of entire anything related to infrastructure and architecture of that time. Yeah. These are the different these are the renderings of the different time periods that we can see. As noted, we were working on 5 different time periods. Over here you can see the 3 time periods that are intermediate 3, intermediate 2, and intermediate 1, wherein we see that the changes that are taking place in terms of walls, their heights, how infrastructure is changing, that we can explain more in the later slide. And this rendering another 2 periods, late 1 and 2, and late 3, inter 1. So the way we started, the way we came up with this model is we started with 2D plans, and then we did the line work on top of the plans. Once we had the basic line work, we started relating it with the sections that we have to give heights and develop extrusions. Additionally, we utilized Mackey's excavation report to cross-check and also provide details like rooms, cesspits, drainage, pavements, etc. in terms of height and depth. This model was supported and developed in parts by looking into different sections that we saw earlier, such as section DD, OP, and KL, which helped in unifying the model into one. For example, the blue lines that we saw earlier represented section DD. This particular model belongs to the period late 1 and 2. And as you can see, we are trying to highlight few details. Like for instance, on the right-hand side top corner, you can see that there are niches in the walls that are evident on the northern wall of room 7 of block 7. Then next detail shows the drainage that is going on the ground, and this is like a zoomed in part, so we are not able to see everything at once, but there are drainages that are passing throughout within the houses, and then the main drainages that are passing around the streets. Then there are well rooms present, and then on the extreme and on the right hand side, you see there is an aperture in the east wall of well room 75 for the drainage, and then there is a cesspit that is 2 feet. So we are trying to relate all the details that we have and understand how the drainage, how the walls, how the columns, foundations, and everything is working. And then and as you can see on the left hand side top, there is a pavement. It's not visible in the rendering right now, but there is a pavement beneath the pottery jar that we have that is present in the room number 29. So we are trying to highlight a few details. And as I mentioned, there is a pavement in the center one. There is a big circle you can see, wherein we can see that there is a pavement, that there is 1 feet. So there are like different levels on ground. It's not like a flat ground. There are like various variations in the grounds, wall heights, and other infrastructure and architectural features.
So I'm just going to jump in here really quick, because I think what I just want to kind of highlight for everyone who's looking at this from an archaeological perspective, this becomes really important because one of the things we're always struggling with these more historic excavations is to have that stratigraphic control, to feel like we actually kind of know what stratigraphy the different kinds of artifacts are coming from. And so by using all of these multiple lines, whether it's the pavement, which of course then establishes a floor level, or it's the drainage, which is often underneath, right? Or if it's the linkages between the drains, those also happen at different times. So by looking at all of these different models and looking at them with this kind of attention to infrastructural detail, we're actually able to gain a lot more kind of stratigraphic certainty, which is kind of one of the things that we need when we're dealing with fuzzy time. Sorry, Priyashi, continue.
No. Yeah, that's fine. So yeah, this slide represents the different features that we are trying to bringing in from all the text and data that Uzma and John showed earlier. And we are like trying to develop it in more detail. So we get all these different layers in the models, and we see how things were actually working at that time and what changes took over during all these different time periods. Yeah.
Mm-hmm. And I'd like to add something very quickly as well, that since the plans and the sections that we have are extremely detailed, suddenly trying to create this 3D model, we had to switch into 3D modeling tools. So for this one, we're using Rhino. And one of the things that we're facing, which is interesting, I mean, if any of you have like interesting suggestions for it, I'm open to it, is that once you move into the 3D modeling softwares, the geometry that you create in data terms becomes dead. So it loses its connection to the data point. So if there is anything written, let's say in a narrative format about a wall, about some brick texture, about a pavement, that is not possible to carry it into the 3D model. And JS softwares like QGIS, ArcGIS, they do not have the capacity to carry this much architectural information. So we're kind of stuck in between these two realms. None of it is doing what we want to do. So we're kind of hacking our way through, making things work for archaeological context. And we're thinking once we're done, we would like to think about moving this into maybe a 3JS or some kind of a JavaScript library we can integrate back into the former data visualization that you see. And probably Manu will have to input the information into the model as well. I mean, not the wall so much, but especially I mean, if you've been to the site, you know the wells have an amazing architectural presence in the site, and also they carry a lot of information about like the height and what they were used to and whatnot. And sorry, Priyashi.
That's fine. So in the slide, as you can see, there are all these different renderings of all the different time periods that we have. And then now we are trying to bring them all together and see what are the changes that took place throughout those different time periods. And then I would like Uzma and John to talk more about this slide.
Yeah. So here, I mean, one of the things, thank you for that, Priyashi. One of the things that we see, the topmost one where it says intermediate 3, that's the earliest levels. And so we're going from earliest all the way to latest. We kind of flipped the sort of usual excavation pattern, because what we're looking at is one of the ways in which we are kind of thinking through changes, morphological changes that happen with the structures themselves. One of the things that we often hear about are like they go from thick walled structures to thin walled structures. They become more complex. But you know, each one of these is a very specific kind of decision, and there's a lot of planning that has to go through in between each one of them. So one of the things that we're now playing with is kind of superimposing each one directly on top of one another, which is a very complicated image to look at and to make a slide of. So we've kind of disaggregated them, for a lack of a better word, because often the assumption often the assumption is that there are foundations and there are walls, and then often walls will be built upon those walls. But actually what we see is that there's a lot of movement and a lot of shift in not just the drainage patterns, but also in the complexity of the buildings themselves. John, I don't know if there was something else. I'm just looking at the time. I just want to make sure we have enough time for Q&A. But I think we have time. I think we're fine on time, actually. So is there anything else that we can think of just straight off the top that we would?
Oh, you know, one thing that I think is very interesting, although, you know, coming from an architectural background, I'm very familiar with looking at plans. Of course, in a different discipline in archaeology, they're drawn differently. But suddenly when we started raising things to 3D, I was a little skeptical about doing this work because of the format, because of what I explained in the previous slide about this geometry dying and everything. But suddenly I think the raised geometry, the three-dimensional geometry becomes a space that is a lot easier to communicate through disciplines. And one of the first things that I start immediately understanding is the colonnaded area in intermediate 3. You know, because in my mind at the time, they didn't have the technology to build lentils. Like, why would they build columns? What does it mean to have a colonnaded area? And the moment that you see, you immediately understand the semi-open nature of the space. So this 3D model is really helping us not only in data sense, but also for us to understand the narrative or understanding the spatial configuration.
Yeah, and also just to quickly kind of there was something that Priyashi had mentioned that I just want to amplify it and highlight, that so much of the ways in which the 3D model has been done is not just from the 2D section, from the 2D plans or the sections, but it's also through the narrative text. So we go through the text, and that's where you find, you know, that there's a niche. Any sort of horizontal information on the walls in terms of height, or in terms of windows, in terms of, you know, where a drainage is coming in or going out, or how the pavement, you know, interlocks with the entrance of the door, like all of those details is actually through the narrative text. So much of the time that this data management project has taken has been kind of excavating that text in some ways, you know, and bringing that to light. And so and much kudos to Priyashi, and like it's I think you've done a remarkable job here, and it's so great to see it. So great to see you there. I think we have one more slide, so we can kind of, I think it's just a thank you to all of those, because of course, you know, this is a relatively new project, and none of it, of course, would be possible without the generous support of, you know, Syed Sardar Ali Shah, who's the Minister of Culture, Tourism and Antiquities, Government of Sindh in Pakistan. Dr. Kalimullah Lashari and Dr. Asma Ibrahim have been absolutely fundamental to getting anything done, and also as interlocutors, right? So, many thanks to them. And then at Shah Abdul Latif University, Dr. Visa and Dr. Taslim Abro have been incredibly supportive, great collaborators. We'll be working more with them. I mean, of course, now there's the pandemic, so we weren't able to go back and set up some of the programs so that the students there could also join us in this work. And then, of course, institutional support from Pratt and from Shah Abdul Latif University.